All right, so the first thing we're going to do is talk about some basic skills that you'll need for lesson 3.1. So the first one is solving an equation by factoring. So if you remember from Algebra 2 and Algebra 1, you've done this before. If we're trying to solve a quadratic equation, quadratics are ones that have x squared as the highest power, and then they might have a linear term and then a constant term. First thing you need to do is make sure you get 0 on one side and everything else on the other. Now the factoring process, the reason we're factoring is because if I can show that two things multiplied or three things multiplied together equals 0, then I know at least one of those has to be 0. That's the foundational aspect of solving by factoring. So factoring means to break this up into the things that are multiplied in order to get it. The first step in factoring, always, 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 is greatest common factor. So as I look through these three numbers, I know that they're each divisible by 3. I know this one's divisible by 3 because 8 plus 4 is 12, and if the sum of the digits is divisible by 3, then the number is divisible by 3. So I'm going to end up with x squared plus 3x minus, and then I'm going to have to divide that by 3, and after a little while you might find that that's 28. All right. Next aspect of factoring is we're going to keep that 3, nothing's happened to it yet, is to take a trinomial like this and try to break it down into factors. And in order to do that, we need to think about, okay, what multiplies to make x squared? That would be x and x. And then on the other end of these parentheses should be what multiplies to make negative 28. What we also want to check then is we need numbers that add to make a positive 3. So negative 28 has to be a negative number and a positive number. And then when I look at that a little bit further, I would find that I would want 4 and 7 have a difference of 3. So 7 would be the positive one and 4 would be the negative one. That would get me a positive 3 when I add them together. And from here you just set each factor equal to 0 and solve it. So when I set x minus 4 equal to 0, I'm going to get x equals 4. And when I set x plus 7 equal to 0, I'm going to get x equals negative 7. And 3 doesn't do anything. It's not x minus 3 or x plus 3 or anything. It's just a 3. And if I were to write that out, it would look silly. 3 equals 0. Well, we know 3 does not equal 0, so that's not anything to consider. So our final answer then would be x equals 4, x equals 7, or negative 7, sorry. All right, now sometimes you get a situation where it's not as easy as that one where we just look for what multiplies to make the last number and adds to make the middle. That only is an issue when we have a number out here in front of the quadratic term, so a coefficient on the quadratic term, and it's not a common factor that I can pull out like I did on the last one. So in these situations, there's lots of different ways to approach it. I know that if this is a quadratic trinomial, if it factors, not all of them do, but if it factors, then it's going to become two sets of parentheses. So I'm going to start with that structure. Now I could do a little bit of a guess and check to get this. I know that 2w times w would give me 2w squared. Again, my first terms should multiply to make my first term of the original. Likewise, I know that something multiplies to get negative 10. That could be 2 and 5, one of them being negative, or it could be 1 and 10. Those are really my only two options. Now what I want to do is end up with a positive w here. So if I put the 5 here, that's going to end up multiplying by, so I'll have the 5 times the 2w, that's going to make it 10w. If I put the 2 here then, because I have to put one of them here and one of them here. If I put the 2 here, that's a 2w, 10w and 2w. There's no way to come up with just 1w out of that. So I know that the 5 doesn't go here. If the 5 goes here, I have a 5w, and then 2 times 2w would be 4w. Oh yeah, there's a way to make a positive w out of that. I would want the 5 to be positive, the 5w, and the 4w to be negative. And so that's just a quick guess and check how you might do that. Now, after that point, you're just going to set those factors equal to 0. Now, if that way doesn't work for you, that's a guess and check. If that way doesn't work for you, then what you might want to do is do what they call the AC method. So I'm going to multiply A times C. Okay, A is my my leading coefficient, C is my constant. So 2 times negative 10 is negative 20. And I want to find the factors of negative 20 that add to make W, like negative 4 and positive 5. All right, when I add those, I get positive 1. Okay, so those are the numbers I'm kind of aiming for. So this alone could maybe help you figure out how to get a 5 and a negative 4 using factors of 10 in the parentheses. You could take that a little bit further, though, and if I just come down here for a second, if I just rewrite this, 2w squared minus 4w, okay, so there's my negative 4, plus 5w, plus 5. Notice these two together add to make a positive 1w. So all I'm doing is rewriting this equation so that it's a little easier to factor. Then we're going to do something called factor by grouping. So I'm actually going to take these and put them together, and these and put them together, and that'll give me something to work with. So if I look at these two, they have a common factor of 2w. So I'm going to pull out a 2w, and I'm left with w minus 2. These two have a common factor of 5, so I'm going to pull out a 5, and I'll be left with w minus 2. So now you can see we actually have a common factor. We have a w minus 2 in both of these sections that I've created. And so w minus 2 must be one of my factors, and then the remaining parts, the 2w and the 5, make up my other factor. And you'll notice how that is the same as what we had up here. So now the only thing left to do is to actually solve it, get what w equals. So w is going to equal 2. And then for this one, w is going to equal negative 5 halves. And again, that's just setting each of those factors equal to 0 and solving them. You get that answer. Okay, so that's factoring.